Hello, everyone. So as we begin our fourth unit, I want to go to the doc here and remind you that if you need earlier material, you just need to come over here to this little scrolling bar and pull it down, and you'll see as you come down to the bottom, the last thing that we did, which of course are these two optional assignments meant for next year's pre-calc students. But if you needed before that, you just go up a little. So the most recent material we just finished is at the bottom, and then just slowly go up and you'll find the other material. And as you go farther up, you'll find the material that we finished more in the past. And then you'll come to the very first quiz, which was over the exponentials and logarithms unit. So just pull down, you'll see it. It is underneath where we are. Okay, so another little unit here, this time with 4 assignments on trigonometry. And today's lesson is strictly going to deal with identities. And that's how we're going to start. And you need to print off the graphing trig functions notes. And that's what you see right here. And this first page is dealing with the basic identities. Okay, and you see this at the bottom, any side of the above identities or any algebraic manipulation of the above identities can be replaced in a statement or equation for the other side. Okay, so in for sine squared plus cosine squared, you can put a 1. So on and so forth. So there are 3 what are called Pythagorean identities, and then reciprocal identities. There's actually 6 of them, okay, and they go back and forth here. And then the definition of tangent and cotangent in terms of sine and cosine. So all of these, the reciprocal identities are sort of by definition, and then the Pythagorean identities are by the Pythagorean theorem that occurs in the right triangle that's part of the unit circle as you wind around on that unit circle. And so you can manipulate by dividing through to get 2 other ones. And basically your approach on today's assignment is going to be to substitute in for whatever you're looking at, you know, so if this is secant and cosecant, try to get everything, I guess, a better way to say it, in terms of sine and cosine, and then reduce. So secant is 1 over cosine. Cosecant is 1 over sine. And you're going to put these in and see what you can come up with. Okay, so what are the rules for dividing 2 fractions like that? Well, the rule is to take the bottom one and invert it and multiply. Okay, that's the rule for fractions when you divide fractions. We've dealt with that a little bit in the past. Okay, so this is sine over cosine. Well, what does that equal? Okay, and now we go back to tangent to ultimately simplify. So try to turn everything, I guess I should say, in the beginning into sine and cosine, then do some algebra and some simplifying, and then see what you can come up with. Number 2, tangent. Okay, so tangent is sine over cosine. So the same thing's going to happen in this. We're going to get a fraction divided by a fraction over 1 over cosine. So this is going to be sine over cosine times cosine over 1. So we're going to invert the bottom and multiply. And that is going to give us sine. when we drop out the cosine. So again, invert the bottom fraction and multiply. And the reason why that is, explain the reason, is you're always trying to convert the bottom part, the denominator, you're trying to turn it into a 1. So you have to multiply the top and bottom of the fraction by that. So that's why that works. Why you do that rule, because you're trying to turn the bottom of that complex fraction, we'll call it, into 1. Okay, number 3. So sine squared plus cosine squared. Anytime you see a squared, you want to look over on the Pythagorean identities. So this is 1 over cosine. What does that equal? This equals secant. So anything that you need to look up will be right here in your work. It's actually pretty simple, as you're seeing, compared to where we're going. And today's assignment should not take you very much time. The expression tangent theta cosecant theta is equivalent to which of the following? So again, everything in terms of sine and cosine, and then do your algebra reducing. So cancel the sines out. This gives you 1 over cosine. And again, you want to look that up. And that is secant. So everything that you're doing is from this page. Okay, show steps to prove that cosine theta times tangent theta is sine theta. So you want to work on the left side on these, and or the right side, and get everything in terms of sine and cosine. That's the strategy here. Okay, so tangent is sine theta over cosine theta. Well, there you go. So you cancel the cosines and you have sine. Pretty straightforward. Cotangent is cosine over sine. And tangent is sine over cosine. Pretty easy to figure out that when you multiply together two things that are reciprocals of each other, you're going to get 1. Okay, prove that secant, which is 1 over cosine, times cotangent, which is cosine over sine. Again, you're looking up what these things equal. Equals 1 over sine. So I looked up what all 3 of those things equal. And then you just do the algebra. My writing is not very good today. And there it is, 1 over sine equals 1 over sine. So you're really working at turning one side into the other, or you are working at turning both sides into a third thing. So I actually turned both sides into a third expression of 1 over sine theta. So long as you can get them equal to each other through canceling terms and algebraic manipulation, you will be good to go. So up here, you see that we just turned it one expression into eventually secant. So it's pretty simple. You just keep working with it. This topic of trig identities can get very complex. We're going to stick to just simple identities and as far as your quiz goes. So you're going to want to refer to this page, and you're actually going to want to print out the rest of these notes, probably up through the 2 tables, and then the rest of this material, when you get to this, you can probably not print that, but just up through the graphing cosine functions, that will be good to refer to.